You're about to watch an extract on simple covalent bonding from one of my live TikTok lessons. So if you find it useful, make sure hit that like button and tell me in the comments what you'd like me to cover next. Enjoy! We're going to talk about the properties that happen with these molecules, okay? So, when it comes to covalent bonds and how strong they are, right? They are really, really strong inside in the molecule. So these bonds in here in the middle, we call those really strong intra. That means they're inside, intramolecular. Okay, those bonds are really, really strong. They take a lot of energy to break those bonds. Okay, but they're strong intramolecular bonds. However, outside the molecule, you've got these things called intermolecular forces. So that means we're looking at the forces now between each of these molecules. And where I come out with my crazy theory that I like to call the Pizza Hut theory. It's an easy way of remembering about intra, and the idea of having these forces in between all of these different molecules. So we've all been at Pizza Hut. Probably, I'm assuming, or you've been at some sort of restaurant. I like to take the Pizza Hut for it because they've got the round tables, which kind of reminds me of the shape of molecules and the shape of those atoms. So inside in Pizza Hut, you're going to have your round tables, okay? Now, I'm going to be sitting at one table. Let's say I'm with my usual, with Ariana Grande and Rihanna.
Damn, it feels good to be a gangster.
At another table, we've got a couple of my friends, 3 friends of mine over there, okay? Now, you'll notice that they're stuck at their table, I'm stuck at my table, okay? But we can still talk to each other. I'm not leaving my table. I ain't leaving Ariana and Rihanna alone at the table.
Damn, it feels good to be a gangster.
But I'm still going to talk to the boys. Okay, here I am talking to Ethan, here I am talking to Shane. Shane's probably like trying to talk to Rihanna as well, you know, typical stuff. You're interacting with the different people at different tables. Now let's say at this table I've got my sisters, my brother-in-law, so they're at that table, and again they're interacting, so they're like telling me, they're giving out to me like, why aren't you letting us sit at your table?
Damn, it feels good to be a gangster.
They're talking to my friends because they know each other as well. You probably have like over on this table, you've got like the paparazzi, like trying to get pictures of me and Bae.
Damn, it feels good to be a gangster.
So they're all over there taking pictures of us and they're interacting there. Okay, there's a whole pile of different interactions going on at each of the tables, but no one is moving from their tables. Inside of the molecule, those atoms are stuck next to each other. They're not going anywhere. They're stuck at that molecule. Okay, they're stuck inside it. So the bonds within are really strong, just like the bonds at our table are really, really strong. Okay, that's kind of how it works. But we're able to interact. We can have the chats to each other. The only thing that ever seems to separate out the silence, or not separate out the silence, separate out the chat and create a silence, or stops us interacting, is when that hot pizza comes along. When that goodness, that lovely hot warm pizza comes in, you add in some heat. Okay, the heat comes in and it breaks those bonds, okay? It breaks those little forces that were causing us to interact, okay? Hot pizza. I love how there's got to be people wondering like, what has this got to do with chemistry, okay? So every time some waitress or waiter comes in with some hot pizza, it stops us from interacting, because that pizza goes to a table, you end up eating your pizza and you don't turn around talking to other people, okay? Now, if we take out the idea of having hot pizza and just leave it at hotness, if you add in heat, if you add in any sort of heat into a molecule, it's going to separate it out from other molecules. So instead of having hot pizza, we've got heat, okay? Heat, thermal energy. If you add in energy, and we say that these aren't people, that these are, I'll do NH3. So that's an NH3 molecule. Maybe this is another NH3 molecule. See how suddenly it goes from it being people in a restaurant to molecules. Molecules interacting with each other. That's what we're looking at. We're looking at a slight change. And those forces that we said that were in between, those are what we call intermolecular forces. Okay, these guys, those interactions, they're intermolecular. They're in between molecules. And the only thing that's separating them is that hot energy, the heat. That energy coming in is the stuff that's interacting, causing us to break and not interact anymore. So these simple covalent molecules, we'll talk about some of the properties of them. So the first property that we saw is that it's going to have low melting and boiling points. And the reason why they've got low melting and boiling points is because those intermolecular forces was what was keeping all those molecules close together. So if we add a little bit of energy and separate them out, they're going to end up turning from a solid to a liquid to a gas really easy. That's why when we look at like the likes of oxygen is a gas at room temperature. If we like try and take energy away from it, eventually it will become a solid again, but it needs just the tiniest amount of energy to turn it into a gas. Likewise, if you think about carbon dioxide, it's a gas at room temperature. Most non-metals that are covalently bonding like this in a simple way where there's only a couple of atoms will end up being a gas. There's very, very few of them that are liquid or solid. So most simple covalent structures, they are gases, okay? That's the key. They've got low melting and boiling points. The second property, they don't conduct electricity very well. Very useful that they don't conduct electricity. Otherwise, if you had a random spark of electricity in the air, you're going to get electrocuted. Not pleasant. Do not want that, okay? So it's really useful that simple covalent molecules don't conduct electricity. That's kind of the key principles to remember about them. Okay, they've got small molecules, only a couple of atoms. They've got low melting and boiling points as a result. They don't conduct electricity. These guys, so when I was talking about the bonds a while ago, these are small molecules we're creating. The bonds in there, keeping them at the table, they're really strong. But outside of it, we've got little interactions with other molecules, but we can separate them by giving heat. So generally, if you think about what we do inside in a lab, if we start adding in energy by like getting out the Bunsen burner, lighting a match and going hell for leather burning stuff, that's what we're doing. We're adding in heat energy. And that tends to be like a big thing when it comes to creating reactions where you're separating out those forces. Inside, in this molecule, there is a bond somewhere here between each of these different atoms. So that nitrogen atom is bonding with a hydrogen there, bonding there, bonding there. Those are called intra. That means it's inside in the molecule, intramolecular. Those take a huge amount of energy to break. So we're not going to try and break those down, okay? Going back to the reference of me being there, you're not going to be separating me from Rihanna and from Ariana Grande. We're sticking at our table. However, there were forces outside of those molecules. So like I said, inside here, those forces, that bond, it's not going to be broken down. But you have these ones in between molecules, intermolecular, okay? That stands for between molecules, okay? Whereas this one was between the atoms, okay? I hope that makes just a little bit more sense. Add some sort of energy and it's going to end up forcing molecules away from each other. But if they're all separated out, we can keep adding more energy and eventually you'll add so much energy that you will break those bonds, which is actually really important because further on, like if you're looking at like when you think about balancing equations and that you're rejigging those molecules, what we're actually doing is we're giving them enough energy to break those forces.
I am the one, the way your son don't need a gun to get respect.